Okay, Assalamu alaikum, dear students. Now, very great, thankful to the all who are watching my channel, and we will start with our class with the record of some graphical presentations. Today, our start with is with the rectilinear or linear graphs. Okay, in this class, we will see how to construct a linear graph. Before constructing a linear graph, I want to explain the uses of the linear graph. Linear graph can be used to calculate unknown concentration of drug, percentage release of drug for the construction of linearity curve, and for the application of solubility profile of drug, for the application of zero order rate constant to check protein binding of drug. These are a few uses or the applications of rectilinear graph. And our today's class is how to construct this rectilinear graph. And for the sake of construction of this graph, we have data. First of all, we will see in case of rectilinear graph, we have two axes. One axis is called x-axis, and other is y-axis. In case of x-axis and y-axis, we will decide dependent and independent factors. On x-axis and y-axis. Dear students, when we want to construct a linear graph, we have two different parameters. For example, we are discussing about the time and the concentration, or any type of the drug in percentage with respect to time. Then we will first observe what are the dependent and other are the independent factors. So dependent factors would be written on the y-axis, and x-axis are for the independent factor. Okay, in our exercise number 1, in our experimental book, we have a data. I would explain how to construct this data. Okay, first of all, I will make the table of the data. We have two ways. One is x-axis, values should be on the x-axis, and other would be the y-axis. Okay, now on x-axis 2, 4, 6, 8 and 10. And on y-axis we have the values 3.58, then 12.87, 24.97, 34.55 and 40.17. 34.95 and 44.7. This is the data. Now we will have to start how to construct it. The values which should be on the x-axis would be the 2, 4, 6 and 8. Okay, when you see the rectilinear graph, rectilinear are the word from the linearity, and we have the same sizes of the boxes. So we will take that type of the graph which have the same number of big division and small division. Now we will start with the x-axis. Okay, start with the 0, then 2, then 4, then 6, 8 and 10. I have written just the difference of the two, but you will see first the highest value and the lowest value. You may take the difference of highest and lowest, and then after getting the difference, you can make uh, the values of the big division, and then by dividing 10 values of the small division. Okay, in case of y-axis, we have the minimum value 3 and maximum value 44. Now we will have to write here, okay, here is, for example, we will start, say, for example, 10, 0, then 10, then 20, then 30, and 40. This is the simplest way to construct this graph. Now we have 44, then we will move toward the 50 also. Now can we check the boxes? 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So we are making some type of the linearity way by taking these type of the steps, by taking the 5 big boxes in case of x-axis and same 5 big boxes on the y-axis. First of all, we will construct a point. For example, we need at 2, we have a 3.58. Now we will count it. If it's a 0 and 10, then we have at mid, we have 5. So in between 10 and 20, here is 15, and 20 and 30, there is 25, then it's 35, and it's a 45. So we need 3.58. Now we will once again divide it. Here is another rule I have already mentioned in the book. You can make a concept of the using the factor, and by calculating the factor, you may take the exact point where you want to draw the line. For example, at 2 we have 3.58, so here is maybe 2.5. Now we can write here 3.58, and then at 4 we have 12.7. Here is 10, 15, then it's a 12. At 6 we have the values of 24, then we will move toward the 24, and once again at 8 we have 34, so here is 34. Then at 10 we have the 44, so we will draw these type of the dots or the line or the points where we coincide the y-axis and x-axis. Okay, when we coincide it, and we will try our best to make straight line. And now we will start our basic concept of the straight line, and what are the information we can get from this straight line. After constructing this straight line, we have the different points. At straight line we have 5 points, so we have to use the straight line equation, which is y is equal to mx plus b. Y stands for values on y-axis, m is slope, x is values on x-axis, and b is actually y-intercept. Okay, we will use two words, interpolate and extrapolate. When we have a points and we want to coincide these points, so coinciding these points would be considered as interpolate. But when we extrapolate it, okay, we will get this point that is called B. By extrapolating, we can get the point B, and a y value, the B is the actually point which is on the y line but having the 0 origin value. Okay, then if we want to make any type of the calculations from this, first of all we will calculate slope. Slope is basically m, and in case of slope is basically m, we will have to take the two different points which are present on the straight line and make a triangle. You are very well familiar with the right angle triangle. Now we have a right angle triangle and we want to calculate the tangent of this triangle. So by taking the tangent of this, delta y over delta x, so we can write tan theta is equal to delta y over delta x. Basically, tan theta is a slope, delta y over delta x. Here we can calculate the slope by taking the two values of on y-axis, which should be on the numerator, and the two values on the x-axis, which should be on the denominator. By dividing the numerator with the denominator, we can get the slope. Okay, after getting the slope value, we can check any value at the x. What would be the value of the y? For example, if we have the value, we need we have the point 0, 2, 4, 6, 8, and 10, and we want to check the value at 5, which is not mentioned in this graph. Now we want to check this value at 5. What would happen? Now we will write slope value. For example, we have slope value 0.23, and then x value is 5, then b value is basically y-intercept, it's 0, then y value can be calculated. So y unknown value can be calculated by using this straight line equation. This equation would be positive if we have the data in ascending order. But if we have the data in descending order, just like in case of IV injections, now our slope would be negative and our equation would be changed now. For example, if we have a data of this format, then same x-axis, y-axis, and same we have a slope, same tangent of this. Now here is theta, delta y over delta x, similar, copied. But concept is now our slope would be in minus, and our equation would be y is equal to minus mx plus b. So this is a profile of the IV injection, and this is the profile of our linearity curve. I hope you understand this concept and you will apply this concept on our exercise number 1 of our biopharmaceutics book. If you have any type of the question, you can consult me. We have a contact number in our channel, and also if you want to any type of the further information regarding this graph, we are always welcome to all of you. Thank you very much.